This is one of a series of Good Answers presentations, offering evidence to answer skeptical challenges to the Bible's accuracy. It's a curious fact that Christians differ with one another about the age of the earth. Some believe it to be 6,000 years old or so, while others make its age to be in the billions. The curious fact? That same question divides those who are not Christian believers. But the reason for this odd fact is not hard to discern. Darwin's theory of evolution is what divides each group. Whether Christian or not, Darwinian evolution, with its need for immense spans of time, will influence how old you believe this planet to be. So it could be helpful to all of us if we found clues to its age. This is part 2 on this topic, and it may be more intelligible if you have reviewed part 1. That lecture detailed some clues that suggest the planet need not be as old as many say. Here in part 2, we will examine some reasons for saying that it cannot be vastly old. As I pointed out in the earlier lecture, in exploring a topic like this, we're doing science, but not observational or experimental science. That deals with what is true here and now. The other type of science, historical science, deals with topics like the Earth's age. And while experimental science can yield absolute proof because others can repeat its tests, historical science, dealing as it does with the unrecoverable past, can only give us clues and only yield probabilities. But the probabilities may be enough to tip the balance on this young versus old question. Let's see. Suppose we start with the sea. Rather hard to imagine our planet without it. So, how old is it? Britannica Online gives us an estimate that many scientists today would endorse. Quote, "The oceans achieved their modern chemical characteristics and sedimentation patterns from approximately 2 billion years ago." They also say the sea itself clocks in at some 3 billion years of age, but its modern processes have been with us for 2, and that's relevant here. I'm reminded of a famous passage in the book of Ecclesiastes. "All streams flow into the sea, yet the sea is never full. To the place the streams come from, there they return again." Ecclesiastes 1:7. As succinct a statement of the hydrological cycle, evaporation, condensation, and precipitation, as one could find, and from a Hebrew king 3,000 years ago. Indeed, streams flow into the sea, but other things do too, like salt. Ever wonder why ocean water is salty? I did as a kid, and somebody told me a story about it. They said that an adventurer went looking for a famous magic mill, which was able to grind out any substance one wanted on demand. He found it, and as he was returning by ship, the mariners demanded he prove that it was really magic. So he said, "Mill, grind out salt." And so it did. But unfortunately, the owner couldn't remember the command to stop the mill. So they watched in horror as it filled the boat to overflowing and sank them. And to this day, it's there at the bottom of the sea, still grinding out salt. Well, I eventually gave up on that explanation. no magic mill. Dissolved salts from the streams and the rivers, over time, make much better sense. In fact, here's a textbook illustration that tells us what we know about the process, and it's quite interesting. Each year, erosion, adding salts to the streams, dumps in 234 million tons. Seepage of groundwater adds another 96 million. Some 2 million tons enter the sea from the atmosphere, but then about 60 million return to it, sea spray and such. The sea floor contributes too, with 112 million tons, while salt mixed with sediments returns about half of that to the seafloor. And there's even some coming up from the Earth's mantle, about 11 million tons. Well then, now it's just a matter of calculation. We find that 458 million tons are added to the sea yearly, with 122 million removed. So the net addition is 336 million tons, each and every year. If the sea waters were originally fresh, then in 42 million years, the salt concentration would have reached present levels. That's a long time, but Britannica says the sea has had its basic qualities for some 2 billion years. Secular scientists will occasionally speculate that the process was different in antiquity, but they have no evidence to support that idea. So they are hard-pressed to explain why the sea isn't far saltier than it is. And that's if it were fresh water at the beginning. But if it had been created somewhat salty, then a 6,000-year-old sea would be entirely reasonable. Bottom line, either way, the seas cannot be even 50 million years old, and the evolutionary timeline is in serious trouble already. But there's more going into the sea than salt. There's sediment, too. Silt, sand, even gravel flow in with the streams, some 20 billion tons on average every year. Some of that is removed from the sea, about 1 billion tons, through the movement of tectonic plates, carried down deep into the Earth's crust. But that leaves us with some 19 billion tons added to the sea every year. Where does it all go? Oceanographers have been taking seafloor cores from around the world for some years now, and we know about how much sediment can be found down there. And if the sea is indeed 3 billion years old, as is commonly asserted, then at this rate of sedimentation, we should find about 250 times more sedimentary deposition than we do. If that were twice as much, well, we could allow some margin of error. But 250 times as much? Something is badly out of whack here, as it is with the salt content. We have a good measure of how much sediment is down there, and it tells us that the sea cannot even be as much as 15 million years old. So much for the sea. Let's come ashore and drive up to Seidling Hill in western Maryland. There we'll find a huge highway cut through the ridge that exposes some fascinating layers of folded sedimentary rock. There was a museum on the site until a few years ago, until budget cuts forced the state to close it, but I visited it several times. Now, as we all know, sedimentary rock is almost always laid down by water. The museum gave us the evolutionary story. the waters retreat, leaving a layer of sediment behind. Over many centuries, that layer of sediment gradually solidifies. Then, millions of years pass, and with them more floods, and more layers to dry and harden. Then, more millennia, and finally we see the multiple layers the drivers pass by each day. Oh, not yet. First, immense tectonic forces stress the layers and bend them, the geologists say, fold them, into the shape we now see. This makes a good story, but for one question that we all might ask. Can you bend rock? Well, you can, very, very slightly. Then sedimentary rock shatters. That's something that has been tested in laboratories many times. Suppose we consult J. Oxt, a mechanical engineer. Professionals like him have to know what stress and strain and compressive forces do to all sorts of materials. Without their expertise, bridges, tunnels, and skyscrapers would be collapsing before we could complete them. J. Oxt studied these layers of Sidling Hill, and he points out that these rocks are bent 10 times more than such rock permits. His conclusion, quote, sediment solidified into rock could not be reshaped in this way. It's physically impossible, end quote. But those folded layers are right there. And now we hear that it's impossible to bend them into anything remotely like that shape. Then how? Only one way, unless we want to violate the laws of physics. All of these layers of sediment must have been laid down over a relatively short period of time, and while they were still soft and pliable, they must have been folded into the shape we now see. Had they had time to harden into rock, this simply could not have occurred. Multiple layers of different kinds of sediment, all deposited in a short period of time? That sounds almost like the evidence of an immense flood. Maybe even a global one. Oh well, Sidling Hill is regularly pointed to us as an example of the millions of years that passed to make its formations. Now, some geologists will say that we can't reproduce this kind of folding in a laboratory, but millions of years of heat and pressure could have done it. And yes, that could have happened. But if it had, these layers would no longer be sedimentary rock. They would have been transformed into metamorphic rock, like quartzite or marble. No, they're still sedimentary. No millions of years for Sidling Hill. Well, where are we so far? Salt in the sea and sediment on the seafloor don't fit with an Earth millions of years old. And the folded layers of sedimentary rock in places like Sidling Hill don't give the old Earth theory any help either. But how about fossils? Everybody knows how dinosaurs died out over 60 million years ago. Or did they? Dr. Mary Schweitzer, working in a lab at Montana State University, believed that they did. And then she found something very puzzling. She was examining a partly fossilized T-Rex bone, a femur, from the Hells Creek, Montana deposits. Fossils from there are classed as 68 million years old. But inside that bone, she found what looked like blood vessels, red blood cells, hemoglobin, and soft tissue. She took it to her department head, who told her to go back and find a way to prove that it was not what it appeared to be. After all, protein structures like those can't possibly remain intact for even 1,000,000 years. Extended study, though, simply confirmed what she and a colleague had found in the beginning. They published their findings, to the astonishment of the paleontologist community. Here's an illustration from that publication. Quote, "Tissue fragments from a T-Rex femur are shown at left, when it's flexible and resilient, and when stretched, as the arrow shows, returns to its original shape." End quote. Challenged by other paleontologists, they returned to the lab for even more exhaustive tests. When they published those results, Wired magazine, which specializes in science and technology, did a long article about them. Here is the concluding paragraph of that article. Quote, "Asara and Schweitzer, in other words, have done just what the critics asked. They've built a rigorous scientific case for the survival of 68-million-year-old proteins from a beast that animates children's imaginations." End quote. It's worth mentioning that the author of that article still believes in evolutionary theory and an old Earth, but he still could not fault Schweitzer's finding. Bottom line, T-Rex can't be even 1,000,000 years old. And the old Earth theory has another problem: the sun. Astronomers call it the faint sun problem. As we all know, our sun is essentially a nuclear furnace, converting hydrogen to helium to generate its immense energy. But the scientists know that this nuclear fusion reaction produces changes in the sun's core, with the effect that, over time, slowly but surely, it is getting hotter and brighter. One of these days, they say, it will go nova and burn us all to a crisp. But it's the sun's past that's relevant here. A sun that is growing hotter and brighter now would have been cooler and dimmer in the past. Some 3.5 billion years ago, it would have been 25% dimmer. And back then is about the time we are told that life emerged. But a sun burning at only 75% would have left the Earth too cold for life, and we wouldn't be here today. So what we know about the sun tells us that the Earth can't be billions of years old. Well, as long as we're out in the solar system, we should notice comets. When I was studying astronomy, our professor called them dirty snowballs, basically ice with some rock in them. They orbit in from beyond Pluto, pulled by the sun's gravity, which swings them in a loop around the sun. If you've seen comets or even photos of them, you have seen the tail they display when near the sun. That tail is in fact ice that is melting and vaporizing to stream out under pressure from the sun's radiation. So they are losing mass with every passage around the sun and gradually breaking up. Some, we know, are already gone. Astronomers calculate that no comet can survive more than a few million years. But if the solar system is over 4 billion years old, how come we haven't run out of comets long since? Here at least the evolutionists have a response. We're constantly getting new ones. There are two kinds of comets, depending on the size of their orbits and how far out they originate. Short-term ones, like Halley's Comet, that return to loop around the sun every few years, and long-term ones that turn up only every few centuries. The short-term ones, we are told, originate from the Kuiper Belt, which is out beyond Neptune. Our space probes have verified that there are indeed many objects out there. The idea is that occasionally some perturbation causes one to be drawn into a cometary orbit, giving us a constant supply of new ones. It's a good explanation, except for the fact that the objects we have observed in the Kuiper Belt are all rocky, not icy, and they're too large. Oh well, there are still the long-term comets. Their orbits are so large that they take centuries or longer to make one circuit, so they must originate from farther out, in the Oort cloud. That's a vast cloud of objects out beyond Pluto, from which an occasional one, disturbed in some way, begins its long fall into orbit around the Sun. And so, our supply of comets is replenished. Fine, but for one awkward fact, no one has ever observed this cloud. We are told of its existence because it is needed to explain the continued existence of comets. Embarrassing, but true. Back to the Earth then to check out its magnetic field. Without compasses, where would we be? Fortunately, though, the textbooks say Earth has a core of liquid iron, which is the source of that magnetism. And one of its benefits is that it deflects much of the radiation coming from space. Without it, that radiation would make life on Earth impossible. We've known about the magnetic field for centuries, and since 1845, we have been measuring its strength. Disturbing news. The field's strength is decaying at about 5% every century. We were able to verify our 150 years of measuring by examining the natural magnetism of metallic objects that date back to AD 1000. It was 40% stronger then. So, every 1500 years, the field has lost half of its strength. And if we calculate back, then it gets really disturbing. Just 20,000 years ago, that field would have been so strong as to heat the Earth beyond the temperature where the sea could exist. No sea then, and certainly no life. Earth had better not be then as much as 20,000 years old. There's one more piece of evidence, and it's, well, a bombshell. The Institute for Creation Research tried something no one else had thought to do. Look for carbon-14 in fossils. Since these are believed to be millions of years old, and since the half-life of carbon, 5,730 years, means that any substance older than 100,000 years would have no detectable C14 in it, it seemed pointless to look for it in such ancient objects. But in double-blind tests, using the best radiological labs in the world, the 70 samples of fossils, coal, oil, and natural gas all were found to contain C14. Here are some video clips of the director of the project.
My part of the RATE project was to coordinate the research on carbon-14. And what we found is like a bombshell as far as evolution is concerned. Well, the essence of our work is that carbon-14 exists in all fossils throughout the geological record at levels easily detected by the current technology. And what this means is that all of these fossils are young. Carbon-14 has a short half-life, roughly 5,700 years. And the levels of C14 we're finding indicates that all these fossils lived at the same time, were buried at the same time, just a few thousand years ago. There's no technique on Earth that can measure levels of C14 in materials that are older than 100,000 years. So the fact that we find so much C14 in coal and other kinds of fossil organisms indicates that their age is much less than 100. One surprising result was that within the statistics of our samples, that there was no difference in the levels of carbon-14 in the coal near the top and the coal near the bottom, which indicates that all of this material lived at the same time and died at the same time. Strong evidence that the entire fossil record has the same age. In addition, we analyzed several diamonds for carbon-14, hoping we would find C14, but unsure about it. And so it was extremely exciting to get the first results back and to find significant levels of C14 in diamond, something like 100 times the detection threshold. And this is very significant because diamonds are formed deep in the earth, on the order of 100 miles down in the earth, generally believed to have formed early history of the planet. And because diamonds are the hardest substance in existence, it's essentially impossible to contaminate a diamond. So what this means is that the earth itself must be young, only a few thousand years old, else the carbon-14 in these diamonds would long since have decayed. And so this carbon-14 must date, we believe, to the original creation of the earth itself.
So it turns out that one of the most important tools for deciding how old the earth is carbon-14. Here's what we have seen. Coal, said to be 300 million years old. C14 says it is less than 100,000. Fossils ranging from reputed ages of 60 to 400 million years, they're less than 100,000 also. Coal and fossils which are supposedly from ages separated by hundreds of millions of years, the tests show that they lived, died, and were fossilized within the same time period, perhaps a few hundred years. Did you see that? Hundreds of millions of years just disappeared from the evolutionary timeline. And diamonds, normally said to have been formed when the earth was young, they too can't be even 100,000 years old. So much, apparently, for a 4.5 billion year old planet. Claims as radical as these may well provoke skepticism. Weren't the tests done by the Institute for Creation Research, which believes in a young earth? Yes, indeed. But the tests were double-blind, with the materials going through a middleman, so that ICR didn't know to which radiological labs the samples would go, and the labs would not know from whom the samples came. So there's no sleight of hand involved here. But were the samples misread in some way, or perhaps contaminated by C14. Well, since this information was published, many secular scientists have tested other samples and found the same results. So the C14 anomaly is now well known. Leibniz Laboratory in Kiel, Germany, is one of the best radiological labs in the world, and they were determined to find if there was some kind of error in the results that everybody was finding. After 2 years of tests, they had to admit, quote, "So far, no theory explaining the results has survived all the tests," end quote. It's real, all right. To summarize where we've been then, those who believe the Earth to be 4.5 billion years or so old have a number of questions to answer. How can it be that sea salt, ocean sediments, folded sedimentary rock, soft tissue in T-Rex bone, a growing sun, disappearing comets, a decaying magnetic field, and C14 found in coal, fossils, and diamonds all speak of a planet that can't even be a tiny fraction of that age? A final word of caution. The evidence in this talk is not intended to prove that the Earth is only 6,000 years old, although this speaker believes it is. Rather, I believe that it shows that the planet cannot be even a fraction of 1% of the age that evolutionary theory requires. That's enough, I would say, to assign Darwinism to the dust heap of history. If you have questions or comments about this presentation, or any of the others in the Good Answers series, you may address them to me, Dr. Jerry C. 4 at yahoo.com.